Good afternoon and welcome to our lesson this afternoon. We are done with the turning effect of force, and now we want to switch our attention to equilibrium and center of gravity. Now, equilibrium is not a new term now because we have interacted with it in the course of studying moment of force. However, I will still define it because it's of importance when we talk about the center of gravity. And equilibrium is a state. It is a state where all forces acting on an object balances out. It is that state where all the forces that act on a body balance out. Now, let us consider a small body like this. Now, and resolve the forces that act on it. Let us suppose we have it being dragged across a bench and resolve the forces acting on it. And we agreed that whenever it is that there is action, it will always call for a reaction. Now, let us assume that this is the weight. Weight in itself is a force. It is going to be counteracted by the reaction of the bench, the reaction force. Then we will have the applied force, and that one is equally opposed by the friction force. Now, when the four forces balance each other, that is where we can say we have realized equilibrium. In that case, friction, for there to be equilibrium, or for equilibrium to be achieved, weight should be equal to reaction force. Again, friction should be equal to the applied. Friction should be equal to the applied, so that we have equal forces acting in opposite direction, and bearing in mind that force is a vector, it means when forces are acting in different directions, they actually cancel out the effect of each other, and therefore we will end up not realizing any movement of this object at that particular point, where now we can claim that our object is balanced. That is what we call equilibrium. Now, on our heading, we also have another term which we equally need to define. called the center of gravity. And what is the center of gravity? It is the geometric center of a body. Other literatures will define it as the point of application of weight of a body. Now that is to mean that all the weight of a body is going to be concentrated at its geometric center. And at this point, that is where we call the center of gravity, or simply the COG. Now, COG of different materials can be established differently. For example, we could start by looking at the center of gravity of regular objects. Center of gravity of regular objects. Center of gravity of regular objects, and I will have a table showing an object, its diagram, and the center, how to achieve the center of gravity. Center of gravity. Now we can start with number 1, a square plate. A square plate. A square plate looks like that. It looks like that. And we can draw some diagonals. And their point of intersection is what we call the COG. So, how to achieve the COG? Construct diagonals and establish their point of intersection. That's for a square plate. We could also have a rectangular note that we said that the COG, or the center of gravity, is the geometric center of an object. Therefore, for a rectangular plate, we will draw it as well. That's a rectangular plate. Then we can construct the diagonals. And find out if at all they intersect, and that point of intersection we can take it to be the COG. So the COG is the point of intersection of the diagonals. The point of intersection of the diagonals. Now, let us look at yet another shape. This time we can consider a circle. This is C, a circle, and find out how do we get to resolve the center of gravity of a circle. Now we draw diagonals, several. Can draw several diagonals. Like that. Then find out whether the diagonals meet at a particular point. This is a circle. We construct the diameters and find out whether they meet at a point, and we can call it the center of gravity. And find their point of intersection. Lastly, let me consider another one. There are so many we cannot exhaust them, but we should consider a triangle. Let us note that here we are talking about any triangle, be it equilateral, isosceles, or whichever. You construct some line from the vertex of the now their point of intersection is the COG. their point of intersection will comprise of their COG. Okay, let us consider an irregular object. An irregular object. For an irregular object, for example, this one, we make holes. We make holes, for example, A. You can call that one B, and probably we can have another one, C. Then what happens is that we suspend the irregular object from the holes and draw. Then after suspending from the holes, you will draw the lines shown or tracked by the string. So what we do, we actually make holes on an irregular object, say hole A, B, and C, and then what we do is that we suspend the irregular object on a stand and we put a plumb line somewhere there, and we can draw the line that has been traced by the plumb line. Now, for example, if you suspend this irregular object through hole A, the plumb line will draw this particular line. If you use B or C, it will draw different lines. And then the point of intersection of the three, point of intersection of lines drawn or traced by the plumb line is the center of gravity. This one is very much practical. You can try it. Just tie the plumb line, and then you can suspend your irregular object using the three holes and find out whether the lines are going to intersect anywhere, and you are justified to take that as your center of gravity. Now, before we advance, I will want to put something across which we noted at the beginning of our lesson, and the weight of an object acts at the center of gravity. Let us say, for example, you are 50 kgs by mass. If you are 50 kgs by mass, it means that your weight will be 50 times 10, which gives 500 newtons. 500 newtons is your weight, because we take the mass and we multiply by the gravitational influence on you. Now, the 500 newtons spells out your weight. But then, what is the point of application of this weight? If we would be in a position to establish your geometric center, then we would take it to be the point of application of your weight. Now, that concept has been utilized in resolving different forces acting on an object. For example, let us look at this example here. A uniform meter bar 100 centimeters long balances at 20 centimeters mark. When a mass of 1.5 kgs is attached at 0 centimeters. That's 20 centimeters mark. We have some mass suspended somewhere here. The mass is 1.5 kgs. And then we are required to calculate the weight of the bar. But we have a uniform meter rule. Uniformity here is supposed to inform us on the point of application of the weight of the same. Now, by virtue of it being uniform, it means at the center, that is where we shall have application of the weight of this particular meter bar. Now, at the 0 centimeters mark is where we have our 1.5 kgs mass suspended. Then we have placed our fulcrum around 20 centimeters mark. Let us try and find the weight of the bar. Now remember that weight is applied at the center of gravity, which is the geometric center. Therefore, let us take moments about the 20 centimeters mark, and this distance here is around 20 centimeters. Then we have this one being 30 centimeters. This is 50. then we can have our setup like that. Now, clockwise movement will be given by weight multiplied by 30 over 100, noting that moment is that product of force and the perpendicular distance from the point of support and to the line of action of the same, so that now we shall have 0.3 W. Then anti-clockwise moment will be given by 1.5. We multiply this one by 10 to make it weight. Then we can multiply by our distance and find out what results from there. We will have 3 Newton meters. Then we can compare the moments and say clockwise moment should always be equal to the anti-clockwise moment. So we can take 3 Newton meters and equate it to 0.3 W. Collecting the like terms, we can have our W being equal to 10 newtons. Therefore, the weight of our meter rule is 10 newtons. Now, it is important to note that at the center, that is where we shall have the point of application of our weight, and therefore we can take the moments and compare the two. Let us take another example. And the question reads that a wooden rod 150 centimeters long balances at 45 centimeters mark when a mass of 2 kgs is suspended at 5 centimeters mark. Now we are required to get the weight. Now probably we start by sketching. We can sketch Now, we have our rod, which is 150 centimeters long, At 5 centimeters mark, that is where we place our 2 kgs. 2 kgs is the same as 20 newtons. 2 kgs has a weight of 20 newtons. Then at the 45 centimeters mark is where we place our point of support, and then we are required to get the weight. Here we shall have we shall have 75 centimeters mark, and that is where our weight will act. Then at the end here is where we have 150 centimeters mark. Let us take the moments. Clockwise moment will be equal to weight multiplied by the distance, which is 30. Change that to SI units so that we have 0.3 W for weight. Then anti-clockwise moment will be this is 40, so 0.4 we multiply by 20. That will give us 8 Newton meters. Let us compare the moments now so that we have 0.3 W being equal to 8 Newton meters. And from there we can calculate the weight. Weight will be 8 Newton meters divided by 0.3 meters. .67 newtons. 26.67 newtons. Let us now go to the states of equilibrium. States of equilibrium, and we have about 3 states of equilibrium. We have the stable, we have unstable equilibrium, and we have the neutral equilibrium. Now let us pick on each one of them and see how they differ. Now, we will do that by looking at a model of a cone. Start by the stable equilibrium. And we will consider a cone we'll consider a cone. Now, we have a cone there, and we can resolve its center of gravity by drawing some lines. And we find out that the center of gravity actually lies at or within the base. Here, center of gravity lies within the base. So any kind of force applied on that cone is not going to alter its state of equilibrium because it lies, the center of gravity actually lies within the base. So, application of force does not alter the position of the center of gravity. How about unstable? Unstable equilibrium. Unstable equilibrium is where our cone rests with the smallest base. With the smallest base. And now, if we try to draw our lines again, so we can establish the center of gravity. We find that the center of gravity does not lie within the base. Therefore, the slightest push, the slightest force that is applied on this cone is actually going to alter the position of its center of gravity because it's actually going to topple. So any force applied alters the position of center of gravity. The last one is the neutral state. The last one is actually the neutral state. And here we have our center of gravity. Clearly, you can be able to note that the cone rests on the biggest base. the biggest base. Now, force will only roll it, but it regains stability immediately. It regains stability immediately. So basically, those are the three that we have. The three states of equilibrium that we have. And we can now look at, we can now go to the factors. Factors affecting stability. Factors affecting stability. And we have two. One is the base area, and number two, we have the position of the center of gravity. Those two affect stability of an object. But how do they affect stability? We start with the base area, and here we know that the bigger the base, the more the stability. The bigger the base, the more the stability. Why do we say that a big base will provide a more stable state? What happens is that a big base gives a big angle of tilt. For you to alter the position of the center of gravity, you will have to turn your object through a very big angle because the area is big at the base. Let us take an example of our cone resting on the widest base. For you to manage to take the center of gravity out of the base, it means you will have tilted through a wide angle. For example, something like that, so that now your center of gravity will be somewhere there. Now the position of the center of gravity will have changed to some point. So the whole of this is the angle we are calling the angle of tilt. Now number two, or factor number two, is the position. The position of the center of gravity. the position of the center of gravity. And for you to achieve a stability, the center of gravity should be as low as possible. Center of gravity should be as low as possible. As low as possible. Now, let us look at a few applications of the same. Yes, the stability, the knowledge about stability important to us in any way. That is the question we have here. And we have basically several applications of stability. For example, number one is the luggage. Luggage compartment of buses. The luggage compartment of buses is always as low as possible, and this one is to ensure that a lot of weight is in the lower part of the bus so that stability can be achieved. As low as possible. Number two, we have the base of a Bunsen burner. The base of the Bunsen burner is always as wide as possible to ensure that the Bunsen burner is stable. Number three is when your light when a passenger alights from a moving vehicle, when you alight from a moving vehicle, you will make sure that your legs you cannot just alight and put your legs together. You have to put them apart for you to ensure that you are stable, for you to ensure that you are stable. Now, how about when carrying a bucket of water? When carrying a bucket of water, you will lean to the opposite side. You will always lean to the opposite side so that you can make your base as wide as possible and ensure that you are stable. That's about all to do with equilibrium and the center of gravity. I will want to give an assignment. Some questions that you can consider when you are revising. Some questions that you can consider when you are revising. Number 1, you can distinguish between equilibrium and center of gravity. We started by defining the two, and I am sure in the course of your revision you can come up with the difference between the two. Number 2, you can describe how to get the center of gravity of an irregular object. You can describe that. We did describe that where we made some holes on an irregular object, then we suspended and we drew the lines traced by the plumb line. 3, you can look at the states of equilibrium and finally you can state applications. You can state applications of stability. You can state the applications of stability. So that's about all on equilibrium and center of gravity. When next we meet, we shall now go to light as a form of energy and see what we can be able to do with it as a form of energy. Thank you.